to us today to specifically talk about brain science and how that relates to the type of work we're doing in standards-based learning. Marie, I'm going to hand over to you and we'll look forward to what you're going to share with us today.
Thank you so much. It's a pleasure and an honor to be back with all of you. And I hope someday I'll get to come and visit again and we can meet in person. But for our purposes today, we're diving in and looking at the brain research that continues to be developed, but really came out of the 1990s, the decade of the brain. And as many of you know, that's where I actually developed my PhD work. And so the focus that we want to really dive into now is looking at how we would even use what we've learned about the brain to embrace curriculum designs, aligning assessment designs, and specifically the why of the standards. So let's take a look at what we mean by that. So you and I are going to call this the story of two brains. When a learner, any learner, is approaching material, there are two types of positions the brain can be in, or what you and I could call two types of brains. One kind of brain, for our purposes, is we're going to call an inchworm brain. And for this one, I want you to think of how an inchworm moves, okay? So the front little feet move forward, and then the back feet catch up. And then the front feet move forward again, and the back feet catch up. And this kind of movement is in a very linear progression. I want you to picture that little inchworm maybe picking up breadcrumbs, okay? Sometimes in the literature, it's referred to as a breadcrumb trail, right? And for you and I, we're going to have this little inchworm. This is a synthesizing brain in terms of brain development, meaning this brain approaches small pieces of either content knowledge or skills and processes them, and then has an aha moment where it synthesizes all that material together and understands why they've been learning it. And this kind of aha moment is described often in education literature. So this inchworm brain historically was also called an academically inclined brain. When this brain is struggling, the natural prescription that educators use is to break down the material more so that it's approachable or accessible. So when this learner is moving toward either retaining material or developing a skill, they're going to need a learning target. Okay. And a learning target, the way we were describing it, is that I can or an I will statement that is either knowledge based, right? Or a skill based piece. Maybe it's developing a product or it's a performance. Maybe it's reasoning. So this idea of taking whatever it is you and I are trying to teach and breaking it down into manageable pieces, okay, is the art craft of learning target design. It's where we start building approachable criteria for a rubric, okay? So this little inchworm brain gets more comfortable when the material is approachable. So if they are struggling, we're going to break it down more for them. Excellent. Now we have our synthesizing brain. But let's talk about the other brain. So the other brain, we're going to describe that brain as a spiderweb brain. And the spiderweb brain is an analyzing brain. And what this means is that the brain needs a comprehensive, okay, why. It needs to know why it's doing something. It needs the larger idea. Think of it as maybe the enduring understanding, a big idea. And if it has that and it's sticky enough, it can connect, retain, and transfer seemingly disconnected bits of information. It can break out any part of that spider web successfully, actually amazingly successfully, and do very well with the material as long as it has an essential question to hold on to and retain each seemingly small piece of information. Without that, it will get frustrated. This brain, when it gets frustrated, it puts down its material and goes, why am I doing this? Why am I approaching this material? Why am I going through these little boxes? When they get frustrated, they absolutely need to know why they're doing it. They need that essential question, or the brain starts to disengage. In a similar way, the inchworm, if they get frustrated, they might say things like, well, okay, I get your idea, but where do I start? What steps do I need to take to make this work? Historically, in the field of education, or at least since the 1890s, we have been developing curriculum and developing assessments to really follow that linear progression model. I kid you not, I think somewhere I have it. Oh, I totally do. Here, hold on. The entire English language fits in a primer this thick. Okay, the entire English language, the Anglo-Saxon layer, the Latin layer, the Greek layer, the French layer fits into this. We used to have two types of nouns, concrete and abstract. Now we have 14 different kinds of nouns. We've broken it down more and more and more to help students with it being approachable. But the idea is we can, in some ways, maybe over break it down. That's one issue that we're facing. The second issue we're facing is the need for us to utilize essential questions in our curriculum design and our assessment design. We never really understood that before. It's why that came out of the 1990s. And can I talk about that for a second? Because right after that, I came into the education profession. I started teaching in 1995. So I was told, hey, you're gonna, need some essential questions. Somewhere around 1998, 1999, that was a big thing. Oh, you're gonna need essential questions. I never really needed essential questions in my classroom or when I was learning math. And so I didn't genuinely understand why, or let me say it like this, how to use essential questions. I honestly thought it was a curriculum alignment thing. And I understood it as a curriculum alignment thing. I didn't understand it as an instructional thing. So I was like, all right, you want me to write essential questions? Rock on, no problem. And then they were like, no, actually, Marie, we want you to refer to the essential questions. I was like, okay, you want me to put them up in my classroom? I will refer to them. I will have the students discuss them. I thought I was using essential questions. Come to find out, when I really learned the brain science behind it, what I was doing was insufficient. I wasn't actually leveraging the essential question to the student's advantage. So what do I mean by that? I mean, hey, if you're going to have an essential question, you actually need to develop for the students the way to answer it, how to answer it, have them wrestle with it over and over and over again. That is how you get the students to really engage with the material. Beyond that, they also need to use the content and skills from the learning targets to substantiate their answers. You don't want the questions to be so ethereal, they just sort of think about it. Or what I was doing, having some students discuss it. And you know how in a class, let's say of 20 students, you might have 5 students participate in the discussion, and then you have 15 student discussion observers. that's not helping them retain the material. That's not helping them build their skills. So you're not going to see the growth that you could have if you have the students answer the essential question in the beginning of the unit, then have them refer to it as you teach them more materials, more learning targets, have them develop additional answers or maybe additional supports to their answer, and then have them return to it again at the end. This kind of development of the answer of an essential question is what is going to get you the gains from having them as a part of your curriculum and a part of your assessments, which I didn't have when I first started. So what does this start to look like? It really starts to support all of that unit plan science that came out of the 1990s. When I say unit plan science, I'm referring to understanding by design with Grant Wiggins and Jay McTighe, backwards design, universal design for learning, international baccalaureate and their template, right? And how they build that unit plan. All of that is based on the exact same brain science. So between you and I right now, I don't want us to over process what we call the things in our unit. Can we agree on that? If you think about the unit more like this bookshelf and you say, okay, I have standards, okay, and then I need to have some level that represents the why. Why are we forcing all of our students to learn this material? And I'm not kidding about that. That's the why. I'm going to come back to that in a minute. In the example I'm showing you right now, it happens to be called Enduring Understandings and Essential Questions. Rock on. We could call them transfer goals. We could call them big ideas. We could call them concepts. We could call them anything that captures the heart of the discipline that we're working with and why we believe as a society, a complex society, that all children should be thinking about and exposed to these ideas. Okay, the second layer of the unit plan is the what level. The what level, now in this example, we're calling it content and skills. We can call them learning targets. We can call them essential learnings, essential knowledge, performance expectations. Pick a feature. We can call them all kinds of terms that represent this more granular level of the curriculum. And then we have the evidence, whatever you and I would accept as evidence of the why. So those essential questions actually have to get answered. And that has to be a part of my activities and my assessment design. And those learning targets, so the content and skills, actually have to be evidenced, whether that's done as a knowledge piece, a skill piece, a performance task, reasoning, or the development of a product. That is basically unit design in a thumbnail. I kid you not. We don't want to get into conflict over what we call the pieces. What we really want to understand is the brain science behind all of those professionals telling us in order to effectively teach a classroom full of kids, you and I need to design a learning experience that has the why and the what available at all times. Let me be clear on this one. I can't sort my students by brain functioning, meaning I can't say, okay, on the right side of the theater, I want all my inchworm brains. And on the left side of my theater, I want all my spiderweb brains. Okay, inchworm brains, here's your learning targets. Spiderweb brains, here are your essential questions. Now learn. All right, I don't get to differentiate by that in terms of grouping. And the reason for this is because the human brain switches in the middle of learning without enough warning. So you and I might be a synthesizing brain in some experiences and an analyzing brain in others. Beyond that, in one learning experience, and maybe you've experienced this yourself, You might switch gears right in the moment. So I might be sitting here saying, oh, okay, I am learning, I'm filling in this graphic organizer because I'm analyzing a piece of text. And then in the middle of it, I go, oh, why? Why am I doing this? When you shift, there's actually a physical reaction. You can see students go through it. Usually they do say something, or their muscles tighten, their body temperature will rise, their blood pressure will rise when the brain reaches a frustration point. That might be an inchworm learner suddenly shifting gears and needing that essential question, needing that analysis support. In the same way, I might be originally an analysis person going, I get it. I'm all in. I understand everything you want me to do for this project, but I have no idea where to start. Again, there's a tightening of the muscles, blood pressure and temperature tend to rise. So knowing that about our students, sometimes our middle schoolers might be like, right? They'll actually make a noise when that shift happens. Watch for it in your class. It's good times. Okay. What that means though, is that in every lesson plan, I kid you not, every lesson plan, we need every activity in every lesson plan to directly align to learning targets and essential questions, not in a loose way, but in an incredibly lockstep way. So what does that mean for you and I? It means this is how we're going to be organizing curriculum learning and the alignment all the way down to our assessments. So 2 to 5 essential questions per unit. Grant Wiggins and Jay McTighe would say 2 to 5 essential questions. Between you and I, the way you're designing curriculum now, I strongly suggest keeping it 2 to 3 because you want to leave room for the students. We're going to want students to be co-creating some of these essential questions. And so you're going to want to give yourself space. The other important thing is it takes time to learn how to answer these essential questions. So it's not something that you want to oversaturate. So let's say I have my 2 essential questions. How many learning targets do I need to have the students work with in order to prepare them to be able to answer those essential questions? Very often we call that what level? Supporting questions. Supporting questions can be looked up in our materials. Supporting questions are very aligned to maybe the content or the specific skills that we're learning at a how do I do it or what is it? The essential questions are more aligned to the why do we do it? Why is it? Meaning, again, why are we forcing every single child to learn this material? When I was a high school math teacher, I really didn't have many ninth graders walking down the hallway saying, oh, the weekend, I couldn't get integers out of my mind. It was just, oh, I can't wait to see what we're doing with them. Okay. So we're forcing students to learn these ideas. So you and I want to know why. And the answers can't be because it's a standard. I'm going to say, why did we as a society make it a standard? You can't say because it's on a test. I'll say, why did we as a society put it on a test? And the answer can't be because the child might someday have the obscure profession where they actually need to use this material. That's not for us to assume we know what 12-year-olds, 13-year-olds, and 16-year-olds are going to be when they grow up in today's modern world. The idea really is to prepare them to be able to think, problem solve, and get enough of a ground laying material so that they can then make decisions about specialization when they either go into an after graduation program or a college. So because that's the foundation that you and I got from these standards, we can't just rote follow the granular learning targets. we need to embrace why. Because if you and I are teaching it because, well, it was part of the program, it's part of the curriculum, then we're teaching it out of compliance, which means we're not really helping the analyzing brains who need that why in order to be their best performance in our classroom. So, for example, let's go back to the math. Why do we force kids to learn decimals and percents? That's going to be in that 5th and 6th grade sequence. Why? I don't want to have an essential question like, how do I convert a decimal to a percent? There's an answer to that. They can look that up in the materials. So it's more about that. Why are we forcing them to learn it? Well, here's an essential question. How can my knowledge of mathematics help me make better decisions? We force all kids to learn mathematics because we use mathematics to make decisions. You can almost see like the assignment, right? Deal or no deal, or right? Or sales, interactions with money. Then the learning targets and the supporting questions could be, what is a percent? What is a decimal? How do I convert decimals to percents? How do I compare like decimals? All of those things live at the what level. The why level is, how do I make better decisions? How do I make my best decisions? And that's the difference. You know, you have a good essential question when it could be at multiple grade levels. I could have that one at kindergarten and all the way up to senior year in high school. Or it's something that can move very easily between disciplines. That's how you're going to start really getting excited about these essential questions. So how do these relate to the standards? Well, here's how it goes. Check it out. Every single set of standards written post 2004, every single one of them has a what level and a why level. So you and I just need to make sure we find the what level and the why level, and then align our curriculums, our units, and our assessment designs to the what level and the why level. So for our purposes today, there's a why level called the capacities of a literate individual. For short, I call it a CLI. A CLI, there are 7 of them, and they're on page 7 of the introduction to the literacy standards. They are going to align to most of our content areas, like Bible, social studies, art, music, because these are all literacies, okay? Phys ed. Now, mathematics, on the other hand, their Y level is found in the mathematical practices, of which there are 8, okay? Those are the lenses. Again, those don't change K through 12. These are not grade level standards. The CLIs, all 7, they don't change K-12. Same thing with the mathematical practices. For science, yours are the cross-cutting concepts. I think now there's 14 of them. Those, again, they're things like energy, cause and effect, structures, patterns. That concept, that idea doesn't change K through 12. So why do we have this layer of the standards? The answer lies in an embracing of the brain science you and I started with. School or education, we absolutely need to get across some pieces of granular knowledge, granular skills. No doubt. No one's going to challenge that. That's why there's a gorgeous section called What. But there's also the purpose of developing in our young learners fluency in having their brain shift lenses in multiple areas, to have multiple ways to view the world. So what does that mean? That means if I were going to look at this watch, okay, I have a watch. If I were going to look at this watch as a mathematician, what kinds of things would I notice? What kinds of questions would I ask? Maybe it would have to do with the numbers. Maybe it would have to do with conversions of time over maybe different time zones. Maybe how big is it? What size is it? Okay, measurement pieces. Another piece would be, could I shift lenses? If I were to look at this as a scientist, what things would I notice? What questions would I ask? Maybe it would be about the material that it's made out of, because it seems to be like a plastic polymer, okay? Maybe it would be about some of the mechanics and the physics involved inside the watch. That's entirely possible. Now, if I were to look at this watch with the lens of a poet, what would be the things I would notice? What would be the questions I would ask? Maybe it would be about the passage of time. Maybe it would be about how I feel. Maybe it would be in describing something to it or the sounds that I hear. The idea is that the why level of our standards aren't worried about granular content knowledge. They're looking at developing in the brain a way or a lens of looking at and thinking about the world, specifically about being able to generate questions so that the granular pieces will help them be able to answer the questions or know how to answer those questions. But if your brain doesn't have the fluency to be able to recognize a mathematical moment, recognize a scientific moment, recognize an artistic moment, then we as a complex society might end up struggling. This is the complete reason why your and my standards look the way they do. So the three options you and I have, the mathematical practices, so that's developing the ability to think like a mathematician. The cross-cutting concepts are developing in the brain a way to think like a scientist. And the capacities of a literate individual is developing in the brain literacy, the ability to communicate, understand communication, develop strong content knowledge, meet the different varying needs of tasks, audiences, and disciplines, the ability to value evidence, comprehend as well as critique, understand other perspectives and cultures, and use digital tools strategically and capably. So these are the structures of a literate human being. And that's what you and I are going to be aligning our essential questions to. And that's going to be for our curriculum and for our assessment design. Okay, so taking a look at that, what makes a quality essential question? I'm going to pause here before I go into this too much. I just want you to turn and discuss for like 1-2 minutes. Turn, discuss what I've presented as the brain science behind your standards design and your unit plan design, and the reason why we have learning targets and essential questions. Just check with your partner, make sure that they're okay with these ideas. And if you have any questions, I want to pause here and maybe you can, Philip, if you get some questions, this is a good chance for me to respond to them before I dive into the next spot. Or give me a thumbs up or a, hey, we're good to go. But turn to a colleague, just process this for a second. And I'm from New York. If you want to talk to yourself, I respect that. Okay, if you could go ahead and finish that thought, please thank your partner for speaking with you. We're going to dive in. I do see a couple of good questions here. I could not have paid you to be a better transition. When you're thinking about the brain science on this design, you end up having to talk about proficiency continuums. So I want to talk about that in a second. Quality essential questions, though, when you are evaluating them, they get to the heart of the discipline, the why. They have more than one reasonable answer. So they're not fetch questions, that would be a supporting question. They often connect the past to the present. They can also connect the material to a personal pronoun. Sometimes just tweaking the question and putting an I or a me or a we or an us in there can really help get more than one example, more than one answer. They often connect to other disciplines, or by simply removing, like, how can my understanding of math help me make better decisions? How can my understanding of history help me make better decisions? That's a good way of connecting it. They also are strong enough that I can return to them over time, meaning you have a really good essential question when a kindergartner can approach an answer to it, a fifth grader can approach an answer to it, and then a ninth grader can approach an answer to it. And you and I could build a portfolio, right, of those increasingly sophisticated answers. But it can also happen within a year. What you see on the right here are samples of essential questions where we're aligning them to those CLIs, or the capacities of a literate individual. Seriously, when you're writing your essential questions, put what mathematical practice, what cross-cutting concept, or what CLI it aligns to right after it. Okay. And that way you now have evidence of your standards. It is a direct alignment. But can we talk about building proficiencies and proficiency continuums the way they're built? Okay, we're going to go a little brain science on this again. Neurologically, when you first drive a pathway, if I were to say the neurons that fire together permanently wire together, what that means is when I'm teaching you a concept, I am, like, maybe the first time I'm hacking my way through a really overgrown area. Okay. The second time I do that pathway, I have maybe it's a path you can see, you can follow. If I continue to do that over time, I might get a pathway, a dirt road, a 1-lane road, a 2-lane road, maybe a multi-lane highway. But to do that, you also need to change the proteins that are being exchanged when a brain wave is firing. So what that means is I start off with concept fluency. Can the learner pronounce the words? Can they define it? Can they describe what we're doing? A concept that has deep understanding, or what you and I would call conceptual deep understanding, is when the learner is now able to explain it. It's where you and I would have the word understand in my standard, or the word explain. Maybe they're making connections. Maybe they're demonstrating it or modeling it. Only after I have concept fluency and then concept deep understanding can I expect operational fluency. Now, I know this looks like very mathematical terms, and the reason why is because the math standards actually directly followed this. We can color code the math standards to this. It's fantastic. However, all of your standards follow the same neurological design, and they take multiple years to develop. Concept fluency might take 1 or 2 years. Then concept deep understanding will get 1 or 2 years. Then operational fluency will usually get 1 to 2 years. This means I can't suddenly start teaching a material in one grade level and expect to get to operational fluency with all my students. It also means I can't take some standards that look like they're just sort of discussing something, or they say recognize something. And I go, well, that's not going to get to a paper pencil test, or I'm not going to put that on a summative assessment. So maybe I'm not going to give it as much time, or maybe I'll just assume that that's evidenced on these other things that I'm getting operational fluency on. We cannot do that neurologically. I have to look at every single standard, and even if it's not something that perfectly aligns to my traditional summative assessments, I need to develop evidence of them, definitely of the thinking, definitely of the ability to explain it. And I need to do that for years before a grade level expects operational fluency. Even after I finish this sequence, I can start this sequence again with a different concept at a higher grade level. So please don't assume that concept fluency is always kindergarten and first grade, and deep understanding is always second, third, or fourth. It's not quite like that. But let's look at a concrete example. So concept fluency. In this example, it is K1 and 2. This is 3 years. These are the standards that align to the development of being able to work with fractions. Okay, but look at the first one. That's a kindergarten standard. The children are composing shapes out of parts of shapes. So they are constructing. When you're developing concept fluency in the brain, you're going to construct and deconstruct. Okay, so in kindergarten, they're constructing. Look at first grade. They're deconstructing. Now they're partitioning circles and rectangles. Notice it's always into equal shares. And now they actually have to pronounce the words half of, fourth of, and quarter of. And it's always those. No third of. At this point, it's half of, fourth of, and quarter of. They have 2 of, 4 of the shares. Notice it just says understand for these examples that they're decomposing more equal shares to create smaller shares. That's the concept of taking things apart or putting parts together to create a whole. But they don't have the word whole yet. Okay, not yet. Notice what we get in second grade. Now they're partitioning circles and rectangles. Again, 2, 3, or 4. Now the 3 is added. They're very precise in this. So again, it's the neurons that fire together permanently wire together. I'm hacking through an overgrown area. I'm making a trail. Now I'm going to be trying to make it at least a pathway that can be recognized. Notice in second grade, they get the word a whole, identical wholes. If they don't get this in second grade, this idea of if I have equal parts of a whole, I then can say 1/2 equals 1/2, but only if the original whole was the exact same. If they don't understand this neurologically as that first pathway, I might get a high schooler who says 1/2 is equal to 1/2. No, it isn't. Half of a planet is not equal to half of a table. I need to understand the concept behind this before I try to get to operational fluency with numeracy. Okay, so you're seeing this development of the concept of parts of a whole, fractions, even with the words half of, quarter of, right? Very young. And this idea of having 2 equal wholes. This is conceptual fluency. Then I get to concept deep understanding. Third and fourth grade, notice the words explain start to come in here. Third grade, fourth grade, explain equivalence of fractions. Before they were just showing it, just doing it, maybe describing it using correct terminology. That's concept fluency. Notice that when you and I are talking about a proficiency continuum, this is really where we are. Sorry. Now let's keep looking about Explaining, this gives me that deep understanding. Now I am 5 years into my concept development when I get to operational fluency. Take a look. Notice here now, we are adding and subtracting. We could even multiply and divide this concept. I am doing procedural pieces with the numeracy, and I can even have it work with word problems. Word problems, though, are not authentic applications. So notice that the whole point here was really to get to the why are we doing this? Very few mathematicians actually get paid to solve problems someone has an answer key to. So what you and I want to do is to be able to connect this progression, what is called a skill progression. If you want to look up the work of Karen Hess, you'll see a lot of work in this area. But our standards actually finish the thought now because they're brain-based, and they actually have standards that say solve real world problems involving multiplication of fractions and mixed numbers. They're giving us an example of maybe with cooking or some other kind of profession or application where this would be used. I can also look at what mathematicians actually get paid to do and find examples for the kids to work through. These experiences are not the same as working through word problems or even scenarios that we set up in the classroom. The idea is for them to be able to connect this to the answer to that essential question, really have them wrestle with the idea, and then be able to maybe work through it even collaboratively. Again, these standards have a hard time aligning to what you and I would call a typical summative assessment, maybe a paper pencil experience. But they are very important standards because they really connect us back to the why. So looking at this, I hope helps you see how the design of the standards absolutely shows you this proficiency continuum. And if I were going to try and capture parts of a proficiency continuum in, let's say, something like a skill progression or a rubric that's going to be able to back down into where the student actually is, I'm going to try and break away from it being, did they follow the directions all the time, and more have it look at, where are they on this? Are my students at operational fluency? Or maybe they're still at conceptual deep understanding. Maybe they're back at concept fluency. And then I can use that rubric to give feedback to the learner on exactly what they have to work on in order to improve their performance. I'm not going to be able to improve a fifth grader's performance on operational fluency by just hammering away at procedural operations. That'll create a false dependence on numeracy and procedural math. What I might want to do is be able to go back and maybe develop that deep understanding, that concept deep understanding, or even develop that concept fluency if I need to. So this is going to be very important for anyone in special ed. This is going to be very important for anyone who's developing a rubric or a way to give feedback to the kids. But it also reminds us there's no such thing as an 8th grade math test. It's a K1, 2, 3, 4, 5, 6, 7, 8th grade math test. And I can't just look at the teachers who were 1 year back. This is something we want to develop as a faculty, because ultimately we're getting held accountable to it as a faculty. So these are examples of types of assessments that you and I are going to be looking at for these authentic assessment experiences that are going to align to those essential questions. Very often they might be collaboratively done, and they might even be separate from those summative assessments or even some of our formative assessments. But parts of these can be broken down to be my formative assessments. Parts of these might actually satisfy a summative, what we call assessment event, which I know many of you are already doing. And then it can then be leveraged into maybe a personalized, authentic assessment for some of our students or groups of students. This is where it starts to get super exciting, but also gets where you and I can't always predict everything or everywhere the students might take it. So I'm going to pause here and invite you to kind of take a deep look at this, maybe pick one or two of these to play with, maybe have a discussion 1 or 2 minutes. I'm going to pause again for any questions. Okay, excellent. If you could finish that thought. Finish that sentence. Please make sure you thank your partners for speaking with you. We're going to be looking at essential questions, the supporting questions, the grade levels, and how they align to the Y level of these standards. AP courses and IB courses, AP courses usually have to have a alignment to a college board or an approved syllabus. You have to have a syllabus that's actually approved. Those also lovingly, fantastically, all have the AP standards are based on the same brain science. The essential questions that they designed and the essential learnings all got rewritten based on the exact same structure. So you're going to be good to go. Use those AP standards. They're set for you to do this. Ladies and gentlemen, I know that brings us to the end of our time. Thank you so much for participating in this conversation. And if you do have further questions, don't hesitate to reach out. Thank you.